Hi, everybody. So today we're going to learn a short physics lesson. This comes from physics. It could be grade 10 or 11. And it's important to study physics because what it is it's about the physical world, how objects move, how they interact with each other. And we're an object in the world. So how do our bodies move and interact with things? How can we make changes in the world, and what changes might objects make to us when we interact with them? This is important even if we never go on to study physics further in upper level science courses, because we're going to live in this, we live in a physical world from the time we're born until the time we die. So if we can make predictions about the effect our actions are going to have, or the effect that objects might have on us, we can be more successful in the world. So today we're going to learn about Newton's first law. This has to do with inertia. Now, what's inertia? Inertia is a property that belongs to each object. Each object has its own inertia, and that is the tendency to want to continue doing what it's already doing. So an object that's still will want to stay still. An object that's moving is going to want to keep moving in the same way, at the same speed. So officially it says here, an object will not change its motion unless acted on by an unbalanced force. That is a net force in any particular direction, okay? If at rest, the object will stay at rest. If in motion, the object will stay in motion at the same velocity. It's important to note that means the same speed and the same direction, okay? So Newton's first law. Who is Newton? Well, this right here is Sir Isaac Newton, and he is credited with discovering these laws. Now, he was born in the 1600s, and this law might not seem that revolutionary to you hearing it now, but at the time, it was quite revolutionary. Most people in the 1600s, vast majority of them, never went to school. The vast majority of them did not know how to read. So people were left to look at the world around them and make observations and just kind of figure it out for themselves. And so people would observe that any time that you maybe threw a ball or pushed an object across the floor, or were swinging in a swing, you pushed a swing, everything would slow down and come to a stop. So it was assumed by people that everything wanted to be still. That was what the law of the time was. That's what people thought. Things just want to be still. So this was quite revolutionary. So how did he discover this? Well, he started out by taking a ball, and he would put this ball on a flat, smooth surface, and he gave it a push, and it went a certain distance before coming to a stop. He took the same ball and the same surface, but this time he applied grease to the surface, made it very slick, and the ball went really far before coming to a stop. And that was with the same push. He applied the same amount of force to each push. Finally, he took this ball and this surface, and he applied a bunch of gravel and rocks and texture to this surface, and it only went a short distance before slowing down and coming to a stop with the same push. Okay, so why? Well, he noticed that it's because the surface, what changed was the surface. What changed was the interaction of the surface with the ball. That's friction. That was the force of friction. It wasn't the ball itself that wanted to come to a stop. And this was a really big deal for the time. This is what we call inertia. The object's tendency to, that object was going to keep rolling if it didn't interact with the friction of the surface, the force of friction. You can see from our terms list here. And in our next lesson, we'll learn how to diagram properly.